So that would be our parent function. What this 4 does, outside changes y and it does what it says. So this is saying take your y's times 4. Okay, some people like to write out these points. And if you do that, you could actually think, if I just took this y value times 4, the x doesn't change, but 0 times 4 is still 0.
4.
And 8. So it's just taking your height times 4. So the 0 stays, but then I have a point 1, 4, 2, 8, and so it just makes my graph get taller. Okay, it's like stretching a rubber band. You know, as you stretch it, it's going to get tall and skinny. What would happen if I put a 1/4 in front of that? Yeah, it would take your height times a 4th. So instead of getting taller, it would get shorter. You know, this is a height of 0 times a 4th is 0. This was a height of 1 times 1/4 would come all the way down here. This was a height of 2 times 1/4 will go to 1/2. And so if it's bigger than 1, it stretches it, gets tall and skinny. If it's smaller than 1, it shrinks it, and it gets short. Does that make sense to everybody?
How'd you get 1/1 to 1/4?
When you have a 4 out in front, it's like taking your y times 4. So my y value is 1 times 4 becomes 4. This point had a y value of 2 times 4 became 8. The x didn't change, just the y.
X is under the bracket.
Mm-hmm. Alright. Is that one okay?
Wait, what you do with the 1/4?
I essentially did the same thing, but I took my y values times 1/4 this time. So the x's still don't change. 0 times 1/4 is still 0. 1 times 1/4 is 1/4. 2 times 1/4 is 1/2. And so that's how I got the new points. Alright. Let's talk about horizontal stretching and shrinking. Outside changes y. Inside changes x. But inside does the opposite of what we think. So what's going to happen is if this number is greater than 1, it will actually shrink. If that number is smaller than 1, it stretches. Okay. Just like on the inside yesterday, adding moved it in the negative direction, subtracting moved it in the positive direction. Inside changes x and it does the opposite of what it says. So, for example, if I gave us the square root of 2x. So the square root function, our normal points are 0, 0, 1, 1, 4, 2. Inside will change my x and only my x. So my y will stay the same. But it does the opposite of what we say. So it says multiply by 2. What's the opposite of multiplying by 2? Divide by 2. So what we will do is divide our x by 2. So 0 divided by 2 is still 0. 1 divided by 2 is 1/2. 4 divided by 2 is 2. So my final graph I have is 0, 0, 1/2, 1, 2, 2, and it looks like this. So think about, I just basically took it and I squeezed it in, so it shrank it. And when you squish it in, it gets taller. So horizontal shrinking kind of looks like a vertical stretch because you're going to smash it in, so it's going to get taller and skinnier. Does that make sense to everybody? Writing out the order pairs is optional, but I think it can be very beneficial on these, especially if you're struggling with it until we get the hang of it. If you write out your order pairs, then we can think about exactly what we need to do on each of them.
So on vertical, X stays the same, you said?
Yes.
And on horizontal, Y stays the same.
So let's just do some examples. I want to draw the parent function and the final transformation on these. What would be my parent function here? Yeah, the chair, x cubed. So 0 cubed is 0. 1 cubed is 1. -1 to the third is -1. You can do more points. If you recognize that this is going to look like a chair, you've got your 3 exact points, then you're good. If you didn't remember that it was a chair, you plug in more. 2 to the third is 8. -2 to the third is -8. So we can get them that way. Okay, writing out these points is optional, but it can help us. This 2 is outside, so is this a vertical or a horizontal? It's 2 times that x cubed, so it's a vertical, and outside does what we think, so it will stretch. Okay, vertical changes y. So my y's are going to change, but my x will not. Vertical y does what it says. So I'm saying multiply by 2. So if we take our y's times 2, 0 times 2 is still 0. 1 times 2 is 2. -1 times 2 is -2. So 0, 0 stays, then I have 1 positive 2, -1, -2. Just like if I stretch my rubber band, it's going to get tall and skinny. Okay, the basic shape doesn't change, just those points on the graph. It's getting taller faster because I'm multiplying by 2. Questions there? Let's look at the next one. This is still talking about the x cubed, so I still have my same parent function. 0, 0, 1, 1, -1, -1. This 1/2 is attached to my x because it's in my parentheses. So inside is x, so it's horizontal, and it does the opposite of what we think. So it will stretch this out. Inside will change the x. That means my y's will stay the same. this says multiplying by 1/2. What would be the opposite of multiplying by 1/2?
Dividing.
Dividing by 1/2. Or that's the same thing as multiplying by 2, right? So 0 divided by 1/2 or 0 times 2 is still 0. 1 divided by 1/2 or 1 times 2 is 2. -1 divided by 1/2 is -2. If I plot my points, we stretch this out horizontally, it's like we put a tack in the middle to hold it, and then we just took the sides and stretched them out. So it's getting wider when we do that. How are we doing so far? Do you guys see where I'm getting my new points? Let's try some more. Alright, I apologize, I don't know why this looks so funny, but we're going to draw 3 graphs. The cube root of x, the cube root of 3x, and 2/3 times the cube root of x. So we need minimum of 3 points. We can always do more if we would like. Do you guys remember what the cube root looks like? Let's pick points and see, since we have several different ideas. Let's see who's right. We plug in a 0, the cube root of 0 is 0. If we put in a 1, cube root of 1 is 1. Okay, if I put in -1, the cube root of -1 is -1. If you're not sure what the graph looks like, that's probably not enough to help you. So if you needed, you could always do more. What's something we could take the cube root of? 8. Cube root of 8 is 2. So this point is optional. Cube root of -8 is -2. And so then we can see it's just like the x cubed graph flipped on its side. It's like the sideways chair. So 3 points is the minimum, but doing more is not too difficult. Alright, let's talk about the first thing I want you to do. The cube root of 3x. The 3 is under the radical, so is that horizontal or vertical? Horizontal. So it's attached to my x, it will change these x values. Inside is x and does the opposite. So instead of multiplying our x by 3, we will divide by 3. So it will actually shrink it. So if we take our points, we are changing only the x. And to get your new point, all you have to do is divide the current x by 3. Okay, so 0 divided by 3 is still 0. 1 divided by 3 is 1/3. -1 divided by 3 is -1/3. 8 divided by 3 is 8/3. -8 divided by 3 is -8/3. So if I plot these, 0, 0, 1/3, 1, 8/3, that's like 2.6 6 repeating. Gives me a 2. Got negative 1/3, negative 1, negative 2.6 repeating, negative 2. And so it looks like this. So that 3 on the inside is a horizontal shrink. It's like you put a tack in the middle at 0, 0, and then you just compress it. You push it in from the ends. Alright. If I asked you to do this one, h of x equals 2/3 times the cube root of x, is that going to change my x or my y? Y. It's on the outside, so it's vertical. Outside does what we think, so will it stretch or shrink?
Shrink.
It's smaller than 1, so it will shrink. So when you're doing your points, this time, outside changes y. So my x's stay the same. So I'm going to do what it says. Y times 2/3. So 0 times 2/3 is still 0. 1 times 2/3 is 2/3. Negative 1 times 2/3 is negative 2/3. 2 times 2/3 is 4/3. Negative 2 times 2/3 is negative 4/3.
So where are you putting these in? The x?
Outside is y, and it does what it says. So I took my original y times 2/3. So if I plot these, 8, 14. So a vertical shrink, you're just taking this thing and pushing it down so it gets shorter. So it looks something like that. Again, writing out those ordered pairs, that is not required, but it does make it easier for us so we can see, okay, am I changing my x or am I changing my y? How do I do that? You guys have questions for me on any of these? One last piece that we are going to add in today is reflecting the graph. And that is our final transformation that we have to look at. So a reflection is just like a flip. If you have a negative in front of your function, okay, so if you think about, let's say we had the square root graph. If I have a negative out in front, what that's saying, out in front changes y, does what it says. So it's like saying if you take your y value and you make it negative. So if I take my y and I make it negative, what happens to my graph? It reflect or flip over, which axis is this?
X.
The x-axis. So if you make your y's negative, it flips it down over the x-axis. If I make my x's negative, so if I take this point and say, okay, I want to make my x negative, so my x come over here, what happens then? Mm-hmm. So that is our final transformation that we have to consider. Those negatives will make our graph flip. We just have to watch over which axis. Does everybody have that down? Let's do example. What's my parent function?
Line.
X,
Decreasing.
x squared
Oh, right.
parabola. Plug points if you're not sure. 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4. Okay, that negative is out in front. It's not being squared, so it's out in front. So what will make it flip or reflect over what?
The y-axis. Or no, the x.
Yeah, if it's out in front, it's making your y negative. Out in front changes y. So if I make my y negative, that flips it over the x. Okay, so if I flip this one, it doesn't go anywhere. But here, 1, 1, if I make my y negative, it comes down. 2, 4, if I make my y negative, it comes down. So if you flip all those points down, you just get this upside down parabola. I want you guys to try one. So parent function and final graph for me. Plugging in points. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. If you wanted, you could do 9, 3. This isn't a line, it's a curve. So make sure your graph does appear curved, not just looks like a line going up. This negative is attached to my x value. Inside is x. So if I were to take these points and make the x negative, it flips it over the y-axis. Or if you think about your point, this is when x is 1, so if x becomes negative, it's at negative 1. X is 4, that would go to negative 4. X is 9, that would go to negative 9. So your actual graph looks like that. I want to look at some problems where we maybe do more than one thing at a time. So we had some yesterday where we had to move left or right and up or down, so I'd like to practice some of that some more with all of our new stuff. I'll probably do 2 problems and then I'll stop for today. So if I'm making a list of everything here, this negative out in front, what will that do?
Across the x.
What will this minus 2 do?
Make it go right
And what about the plus 1?
to up one.
Okay. My parent function is x cubed. 0 cubed is 0. 1 cubed is 1. If you wanted, 2 cubed is 8. Negative 1, negative 1. Negative 2, negative 8. You don't have to have all of those, but you can. Alright, when you have multiple transformations like this, the order doesn't necessarily matter, except up and down has to be the last thing we do. Okay, so if you're going to flip, you need to do that before you move up and down. So if I just start here, if I flip over the x, if you flip at 0, 0, does it go anywhere?
No.
No. And then I take that point, right 2, and up 1. Okay, 1, 1. If I flip that over the x, it goes to 1, negative 1. It comes down. And then we need right 2 and up 1. If you had 2, 8, if you flip that over the x, it goes to 2, negative 8, right 2 and up 1. Negative 1, negative 1. If I flip that over the x, it goes to positive 1, right 2 and up 1. -2, -8. If I flip that over the x, it goes -2, +8. Write 2 and F1. So my final graph looks like that. All right, last one. What will the 1/2 do? It's outside, so it's vertical, it does what we think, so it's like taking your height times a half, so it will shrink. What does the +2 do?
Left.
And the -3?
Down 3.
Parent functions, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Okay, when we have this vertical shrink, it's outside, so it's y, it does what we think. So all we're doing is multiply your y by 1/2. So if I take this first point, my y value is 0, times a half is still 0. And then we go left 2, down 3. Okay, next point, if I take 1, 1, what the y value right here is 1. Multiply that by a half, so your height becomes 1/2. Then we go left 2, down 3. If I take 4, 2, right here my y value is 2, times 1/2 is just 1. And then we need to go left 2, down 3.
Wait, can you do that again?
So my point here is 4, 2.
Okay.
First thing I did was multiply your y by a half, so it becomes 4, 1. So we're right here. Then I went left 2 and down 3.
Okay.
My next point is 9, 3. If I take my y times a half, you get 1.5. Then take that left 2, down 3. So we get this shorter graph that's been shifted down and over. We have learned everything from this, but we are going to practice more tomorrow and Monday with all this transformation stuff that we have, so we're not moving on for a little while. There is a Math Excel assignment open, so it's not due until Monday. You do already know how to do all of it, but tomorrow we will be practicing some more